Today we introduce electronic expansion valve, the electronic evaporator controller. Well, let's start with the basic terms. What is an electronic expansion valve? An electronic expansion valve has the function of feeding the evaporator with liquid refrigerant and maintaining a fixed superheat. The types of electronic expansion valve are A. Opening and closing time control valve. These electronic expansion valves are actuated by PWM regulation, which means that the opening time is controlled as needed. Example of these valves, the Danfoss KV series. B. Variable bore area valves. In this type of valve, the size of the orifice that the refrigerant uses to reach the evaporator is controlled. This regulation is carried out through a stepper motor. A precise positioning is achieved for the optimal control of the liquid injection. Example of these valves, the Danfoss ETS series. In order for any electronic expansion valve to regulate, a controller or electronic system is required, which measures, through sensors, the evaporation pressure and the evaporator outlet temperature.
What is an electronic evaporator controller?
The electronic controllers for the evaporator, with its corresponding valves, are complete control systems for refrigeration applications and rooms in the commercial refrigeration sector. We can list the main features of the electronic evaporator controller as follows. 1. The main function of the electronic evaporator controller is to regulate the injection of liquid refrigerant into the evaporator. 2. The supplied liquid refrigerant is controlled by a signal from temperature sensors or with a pressure transmitter. 3. Depending on the type of electronic control for the evaporator, regulation can be done. 2. Using an AKV expansion valve. B. Using as regulation a solenoid valve together with a thermostatic expansion valve. C. Using an ETS electronic expansion valve, either with a unipolar or bipolar stepper motor. 4. When working with an AKV type expansion valve, or total opening and closing valve, the evaporator controller decides, based on the reading of the sensors, the time that the refrigerant should be allowed to pass through the evaporator. 5. The controller opens and closes the AKV valve, based on the sensor readings. The valve opening is independently adjusted so that the evaporator provides the optimum amount of refrigerant at all times. 6. When working with CTS electronic expansion valves with stepper motor, the controller acts by regulating the expansion valve passage, based on the temperature and pressure readings obtained by the probes. 7. Through the use of a pressure sensor and a temperature sensor, a correct measurement of superheat is achieved in any condition, which ensures a very precise and robust control. For example, superheat is measured by the pressure sensor, PE, and temperature sensor, STU. The temperature of the installation is registered through one or two temperature sensors, located in the airflow before the evaporator street or after the evaporator's fore, respectively. Additionally, the SSIX product sensor, which can be optionally used in the installation, can be used for recording and alarming of the temperature near food. The evaporator temperature is recorded by the SFIVE sensor, which can be used as a defrost sensor. 8. Depending on the model of the evaporator controller, it can control 1, 2 or more evaporators. 9. With the use of the electronic controller of the evaporator, there is the possibility of increasing the suction pressure, decreasing the electrical consumption. 10. Electronic evaporator control ensures the lowest possible superheat, bringing performance closer to a flooded evaporator system. 11. Depending on the controller model, control of one valve for one evaporator, one valve for two evaporators, two valves and two evaporators, and many other combinations can be realized. 12. depending on the application. With the use of the electronic evaporator control, the following defrost methods can be chosen. 2. Natural. The fans remain active during defrost. B. Electric. The heating element is activated. C. Hot gas. Here, the solenoid valves are controlled so that the hot gas can pass through the evaporator. 13. An electronic evaporator controller can allow the management of a compressor station.
For example, if one compressor cannot keep the temperature within the differential, the second compressor will also start.
Also, if one of the compressors has been running alone, for example for 2 hours, the compressors will alternate so that the running time is balanced. 14. To save energy, an electronic evaporator controller can pulse control the power supply to the evaporator fans. 15. The electronic evaporator controller can measure humidity using a 0 to 10 volt signal from a humidity sensor. Humidity control works like a simple on-off signal to a humidifier. 16. If the humidity drops below the defined switch-on value, humidification will be started by a signal to a humidifier. 17. An electronic evaporator controller is also used to prevent system malfunctions. You can set the time that the compressor can be running once started and the minimum time that it must remain stopped. 18. With an electronic evaporator control, the time delay for the coupling of two compressors can be controlled. The settings indicate the time that must elapse from the activation of the first relay until the activation of the second relay, which controls the compressors. 19. Choice of the connection method. For the operation of two compressors, either sequential, first to connect, last to cut, or cyclical, with equalization of the ignition time. 20. In addition, the use of the electronic evaporator controller allows the management of parameters such as A. Defrost stop temperature. B. Times for defrost intervals. C. Maximum defrost time. D. Defrost delay when turning on the equipment.
And
Drip delay time. F. Fan delay after defrost. G. Fan start temperature after defrost. H. Fan status during defrost.
Yo.
Defrost stop by time. J. Defrost delay after emptying. K. Fan control when disconnecting the compressor. L. Evaporator temperature at which the fan stops. M. Selection of the compressor deactivation delay when opening the damper. Thanks for being with us. We look forward to your subscription to the channel. See you in episode 9 of our series.